How do internal combustion engines generate power? Have you ever wondered how the engines in cars and motorcycles work to keep us moving? Internal combustion engines are fascinating machines that convert fuel into power. Let's break down how they generate that power step by step. Internal combustion engines generate power by turning the chemical energy in fuel into mechanical energy. This happens through a process called combustion inside a special area known as the combustion chamber. The process involves mixing fuel with air, compressing that mixture, igniting it, and then allowing it to expand. This expansion creates pressure that moves engine parts to produce usable power. The common method of operation is through a four-stroke cycle. First, during the intake stroke, the intake valve opens. The piston moves down in the cylinder, pulling in air or a mixture of air and fuel. This mixture is referred to as the charge. Next comes the compression stroke. Here, both the intake and exhaust valves close. The piston moves back up, compressing the charge into a smaller space. This compression raises the temperature and pressure of the mixture, making it ready for ignition. Then we reach the power stroke. Near the top of the compression stroke, the charge ignites. In gasoline engines, this is done with a spark plug. In diesel engines, the high temperature from compression ignites the fuel. The combustion creates a rapid increase in pressure, pushing the piston down with great force. This downward movement is what converts energy from combustion into mechanical work. Finally, we have the exhaust stroke. The exhaust valve opens, and the piston moves back up, pushing out the burnt gases from the cylinder. This clears the way for the next cycle to begin. The movement of the piston is connected to a crankshaft through a connecting rod. This setup changes the piston's up and down motion into rotational motion. This rotational motion is what ultimately drives a vehicle's wheels or powers machinery. From a thermodynamic viewpoint, internal combustion engines function as heat engines. They absorb heat energy from burning fuel, convert part of that energy into mechanical work, and releases the remaining energy as waste heat. The efficiency of this conversion is influenced by thermodynamic laws and the design of the engine. Internal combustion engines can be classified based on the number of strokes they use, such as two-stroke or four-stroke engines. They can also be categorized by their combustion process, with spark ignition engines using constant volume combustion and diesel engines using constant pressure combustion. In practical terms, internal combustion engines are widely used in transportation. They offer a good power-to-weight ratio, quick start-up times, and have been developed over many years. However, they also face challenges, such as fuel inefficiency, where only about 25 to 30% of the fuel's energy is turned into work. Additionally, they produce emissions and relying on fossil fuels. So, internal combustion engines generate power by burning fuel in cylinders to create high-pressure gases that push pistons. This process transforms chemical energy into mechanical energy through a controlled thermodynamic cycle. Understanding these principles helps us appreciate how these engines operate in our everyday lives.